This video presentation is going to provide installers, technicians, distributors in the field with a procedure on how to strip the Vector actuator so that we can inspect the inside of the operator, pick up if there are any problems with the operation of the unit, and then reassemble the unit, making sure that it obviously will operate reliably in the field thereafter. The most important thing to ensure before you start the process is that you do have the original manual override keys in order to operate the manual override mechanism. As you know, the Vector actuator comes with non-key-to-light keys, so you must make sure you have the ones that do fit the particular operator that you're going to be servicing. For the sake of this exercise, we're going to make use of our table with a hole in it. It tends to support the actuator better and make the disassembly process that much easier. The first stage is to release the cable bush, and as a hint, it uses a 17mm spanner, but slip the cables through the ring part of the spanner, and it's just a little bit of a fiddle to get it to actually slip over the nut of the bush itself, but once that is done, it makes it that much easier to actually loosen the bush. Once you've loosened the bush, remove the spanner. It's a lot easier then to use the actual open ends of the spanner to unscrew the bush. Having unscrewed the bush, we can actually remove it off the cable completely. The next stage will be to loosen the dome nuts which secure the actuator tie rods and obviously clamp the whole actuator together. It's going to be much easier if you can use a 3/8 socket set using a 10mm socket. When you are removing the nuts, it should happen that the nut actually just unscrews off the tie rod. But if the nut is a little bit corroded to the tie rod, it could start to try and unscrew the tie rod from the front housing. In that case, remove the tie rod completely, unscrew the nut from the tie rod, but before you proceed with further disassembly, you must screw the tie rod back into position, because this tie rod holds all the components inside the unit together. Once we've removed all three nuts, we can then proceed to lift the rear end cap off the back of the actuator. What you must remember is that there's still an O-ring around the cable at the entry point of the rear end cap. When we lift the rear end cap, we must be careful that the O-ring is actually now going to restrain the cable. Now there's a little routine that we follow in order to expose the O-ring and then slip it off the cable. Grant will show you. Notice how he lifts it, grabs it, and now he can slip the O-ring down the cable. He doesn't need to take the O-ring all the way off, he can just leave it on the cable. Right, now he can actually remove the end cap and slide it down the cable and just leave it lying on the bench. Just to recap where we got to at this stage, using the 17mm spanner, we've unscrewed the cable gland. Using the 3/8 10mm socket, we've taken off the three dome nuts. We've taken off the rear end cap, but making note that we've slipped the O-ring down. The next stage is just to slip off the rear nylon flange. And similarly, you can just slip that back along the cable. The next stage is to disconnect the motor cables. Use the bullet plugs which hold them together. Try and rather pull on the actual lug itself. Don't use the cable. Note how the bullet lugs have been polarized, so there's no chance when we actually reconnect the cables afterwards we get them the wrong way around. In any case, they are color-coded, blue to blue, black to black. Next stage, we remove the three short tie rod spacers. There's another tie rod spacer at this point here, and it's slightly longer, so that's how we differentiate it. These are the short tie rod spacers. The next stage in the disassembly process will be to remove the motor and gearbox assembly. Please note, we want to make sure that the housing remains in place. Step 1, ensure that the manual override key is in a fully clockwise position. Fully clockwise position. Right, the next stage will be the actual extraction of the motor. Now note, you must hold firmly onto the casing because we don't want to lift the casing as we lift the motor. Then, notice how we tilt the motor forward towards the key side of the casing. Almost a wriggling process as we start to lift the motor out. When you remove the motor, do make sure that the sensor harness remains behind. If the harness cable does come out, in other words it is loose, it's an indication that it has loosened itself or unclipped from the sensor and would give you either the symptom that you have a sensor failure, or if you checked in your diagnostic screen, you would have noticed that you got no position count, you had no count or feedback from the actuator. Now we can slip the body off. Remember to feed the cable through the body. And note where the sensor clips in, the sensor harness clips in onto the sensor itself. Let us actually remove the harness sensor. Now, first process is to make sure you grip the board. Don't actually rip the board up. And it's also recommended that you take a small screwdriver and use that to actually wedge the clip out of position rather than actually yanking on the wires. But you'll find that as long as you're applying a very small amount of tension, you can actually lever it out. Now, the sensor PC board actually slides out horizontally from the side. The first thing we have to do, though, is align these tabs here from the counter wheels. The counter wheels must allow the eyes on the other side of the board to actually slip past. So notice how that would not allow me to remove the PC board. I align it so that I can now remove the PC board. Then there's a little clip that holds the PC board in position. Just prise this to the side, then take a screwdriver, grip it behind, and we can slide it very nicely out. Just in case that image wasn't very clear of this counter disc, notice how it's got these slots in it, and you must align the slot, the open slot, with the groove where the board actually slides in or slides out. The sensor board is a very critical component in the operation of the Vector actuator, and you must make sure that there's absolutely no grease on these eyes at all. And it's also quite a good idea to have a look and see that the eye itself you can see it's a slightly raised section, almost dome section of the clear plastic molding, and it must be shining through this gap in the black plastic part of the sensor. And likewise check that, because just as a brief explanation, we have an infrared component here which is shining a beam of light across to a photosensitive transistor on this side. And if there's not a clear path between these two components, one can pick up a problem. So that then moves us to the next thing to check, and that is on the counter wheel itself. Make sure that there's absolutely no grease, not only on the outer face but also on the inner face. Because even if it hasn't deposited grease yet, it could, with future operation, deposit grease onto the sensor eyes and cause that classic hasn't found the sensor or no position count problem that you experience. Just another visual inspection that you should do is just make sure that all the counting teeth are there, although very unlikely that any of these teeth would have broken, but obviously, having taken the time to open up the unit, make sure that all the counting teeth are there. In other words, just make sure that there's a consistent gap in between each tooth. Just something else to check with the little sensor board. Make sure the actual plastic holder which supports the eyes
they're nice and vertical, and also make sure that they're nice and securely soldered into position. You can feel here, just as I'm trying to wriggle, these things are nice and securely soldered. Turn it over and just check for perhaps any dry joints. That is critical. If you really are concerned, you could take a hot soldering iron and just make sure that each joint is correct. If you do notice any evidence of these sensors being a little bit loose.
The next stage of our checking process is to make sure that we have a fully continuous cable. In other words, we want to check continuity between one end of the cable and, of course, this sensor clip at the other end. Now, it is recommended that what you do is just pull on the cable, stretch it a little bit, make sure that if there are any breaks due to the operation of the machine, that you obviously accentuate the problem that could exist. To check your continuity, put your meter into continuity mode. You'll know it's in continuity mode. I touch the two prongs together. You get the distinctive tone indicating that obviously we have a short circuit. Let us go through each point then one by one. Let me start with the thin blue line. I grip one probe on that line and I press onto the blue contact there and make sure I have continuity. Let me just do it with the red so you get a feel of what I'm trying to do. Grip the red, go on to the next point. Okay, and we proceed to complete that. The next stage of our visual inspection will be to check the high-speed stage of the planetary gearbox. We're going to have a look at the planet gears and also have a look at the outer ring gear. And as we turn the gearbox, make sure that all the teeth are there, none are being damaged in surface. Do check this carefully. Although it's very unlikely, make sure that the push-on fixes are holding the planet gears securely in place. As you rotate the gearbox, make sure that there is very free movement. If you do encounter any resistance as you are rotating the high-speed stage of the gearbox, then clearly there could be some fault in the worm mechanism, which would obviously require deep investigation. The slow speed section of the planetary gearbox is housed inside this part of the casing. And we don't recommend that you actually split this apart because this is filled with grease. And the last thing we want is for grease to come out of this area and get into the area where your sensor is housed. The next inspection will be the manual override mechanism. I'm going to get my cameraman just to shine down into the tube, and you can see the cam which has been bolted or fastened to the cam lock itself. Now that cam operates between these two flanges on the motor, and notice how as it actuates it pushes this away from the motor and now allows free movement, and obviously when it re-engages it pushes back and engages with the spline teeth on the brake. So that is the action. Push apart, push back in. Now if the manual override mechanism has been upset slightly and in fact has actually popped off completely, then let's examine the different components that make up this part of the mechanism. We have what we call here a nylon detent, and this allows the popping action. That's the clip in one direction, clip in the other direction. Make sure that you see no evidence of wear on this particular component. If this part has actually disassembled itself, there's a neat little procedure to reassemble it. First of all, take the spring, make sure the, let's call these clips or the teeth of the spring, face downwards. They must face towards the teeth on this component. You slip it through the slot, making sure that it comes through on the other side. Can you see that? Teeth facing down in this open area here, or recessed area in the molded component, and the clip facing through that. Then I take this mast or mast end section, and that slides through
the middle of the plastic component. When you put the manual release back into position, it's one nice solid action to clip it back into position. Let us now just check that the brake itself is operating correctly. Notice it will not freewheel on the motor itself, but you can actually jiggle it backwards and forwards. When I rotate it in one direction, it will stiffen up, and likewise if I rotate it in the other direction, it will stiffen up. If at this stage everything seems to be working fine and you've done all your checks correctly, we can actually proceed to reassemble the unit. However, if you are concerned with the operation of the gate, if it does seem to seize itself, then let us proceed to inspect the brake itself. Let's unclip the manual override, as we've done previously, and let's take off this circlip here. Good. Use a small screwdriver to help with this process. Okay. You slip the brake off. Notice the dowel drive pin. You can take that out and just put that aside. Next thing, let's examine the inside of the brake. First thing to note for are the springs. They stretch between two sets of shoes, and make sure that they actually are engaged on that side and on this side. Let's have a look at what we call the cone, or to compare it to a motor vehicle would be the brake disc. What we're doing is looking for any appreciable wear on the cone. And also make sure these clips, which are part of the brake shoes, make sure that they are intact and they're engaging with their mating part. Before we proceed with the reassembly of the unit, as just a precaution, just check that the output shaft of the motor is turning freely. We can now start with the reassembly of the unit. Take our dowel drive pin, slot it into the shaft, pick up the brake. Now the next thing we have to do, notice the slot in the brake mechanism which is going to engage with the dowel pin. You must orientate the slot just alongside these little clips here, so that obviously the dowel pin will engage. If it's at any other point, you'll find this part of the cone will actually foul and not allow the dowel pin to re-engage. Before I actually slip on the brake, having obviously got the slot correctly aligned inside the mechanism, just rotate the shaft so that the pin is at 90 degrees to these claws that face forward. And again, make sure it's properly centralized. Slip it on. And I just keep turning it until it engages. There we go. Slip on our detent and replace the circlip. Once we fitted the circlip, same procedure again to reassemble the manual override. Slip that into position. And nice firm action all the way on. Okay, let's proceed to the next stage. Let's reinsert our sensor PC board. Noting once again that the teeth are aligned and that the little plastic clip engages with the back of the PC board. Just check it, rotate the system, make sure that the teeth are able to move through the slot without fouling with the sensor eyes. Next stage, putting the body back. Notice that the label is at the bottom part of the body, and he's going to turn the cam lock fully clockwise. That's most important. Cam lock fully clockwise. He's going to feed the sensor cable through from the top of the housing and pull it out from through the bottom and clip it into the sensor unit. It is a polarized plug, so it can only go in one way. Then he's going to slip the body over the three tie rods and drop it into position. Let's take a look inside the operator just to make sure we got everything right before we start to reinsert the motor. Notice that again we re-emphasize the cam lock fully clockwise. Can you see the cam is actually facing up towards you? And then also pan across, you can see the cable for the sensor is routing out on the opposite side of the housing. Make sure it's not fouling with anything. Right, now we can insert the motor. Notice how we have to have the sensor cable engaging with the cable guide. Make sure that the tie rods actually slide into their respective slots. Just before we drop the motor in position, the camera is going to come forward just to see how the plastic flange engages with the actual aluminium. And notice also how the cable is nicely in its cable guide. Now we can drop it down. Now, as I drop it down, at this particular point, note that the motor hasn't gone past the cam lock. We now need to get the motor past the cam lock. So we tilt the body of the motor towards the top part of the motor towards the cam lock, understanding that obviously the manual override will now be tilting away from the cam lock, and it allows us to get it past the cam lock and into position. Once we've obviously got the motor bedded down, we can now just check the operation of the manual override. You'll notice as I turn the key, we get a nice, easy actuation of the manual override. Replace our short spacers over the tie rods. Just use that one to help push it down. Use that one to help push it down. Let's reconnect the motor leads. As we explained earlier, they are polarized, so there's no chance we can make a mistake, but as always a precaution, blue goes to blue, black goes to black. Right, next thing will be the flange. Notice the orientation of the flange. Obviously the deeper side will face forward, slip the wires through, feed that through the cable, drop it into position, making sure that these parts actually engage with the tie rods. Press down. Now we can slip on the rear housing. Again, just have to feed the cable through the cable entry point, and I feed the housing down the cable. Now, note the orientation, cable entry opposite to where the cam lock is. Feed it down. Again, notice that flat face lining up with that flat face onto the tie rods. Just get them aligned. Just pull on the cable a little and make sure it is seating nicely. We take our 3 nuts and we screw them on. Do be careful when you are putting the nuts back onto the tie rods. Don't cross thread the nuts. You'll find it actually easier to insert the nut into the socket, then place it over the tie rod, and you'll find it actually screws on very easily. Tighten them until they're nice and firm. Don't over tighten and strip the nuts. Almost near the end, slip on the O-ring, slide that down, don't be tempted to use a screwdriver to press the O-ring down. Rather use the cable grommet to do that. Note the orientation, the threads must face forward. Slip it on, down, into position, rotate and tighten up nicely. Right, let us test the unit. Standard battery, 12-volt battery. Do note the motor wires will be the thicker blue and black wires. You've obviously hopefully learnt fully clockwise the unit is engaged, fully anti-clockwise it's in manual override. Just check that the manual override is working nicely. Make sure it's engaged when we're going to drive the motor. Just touch the motor leads across the terminals. Change the polarity and it should drive in the opposite direction. Check the manual override. Fully anti-clockwise. If I run the motor, nothing will drive. You can just hear the motor running in the background. Well, this concludes the reassembly of our Vector actuator, and now we can return the unit back to site.